Hello and welcome back, and in this video we'll be talking about how to actually have our clouds being exported into Unreal Engine using the labs, and how we can make, as you can see, I have this little scene. It's basically Electric Dreams, a PCG, and I will just start enabling our clouds so you can see what's going on. And in fact, they really are just, as you can see, they really are just planes that we can move around, we can tweak around, we can create all kind of different material instances for them, and that's exactly what we're gonna do. And let's get started. And just before we begin, I wanted to say that the current plugin for creating flipbooks is a little bit buggy. The latest stable version it supports is Unreal Engine 5.0, and there it works pretty good. However, the PCG content works in 5.2, so with that in mind, just keep in mind that we might encounter some bugs, but the newer version is coming, and Mai told me that it's going out soon. And when this is out, I think I will record new videos to cover what's new and what's fresh and how to use the new versions. But we have what we have right now, and let's just start working with our clouds inside of this. So in the previous video, we learned how to export our VDBs and render them in Blender. However, in this one, we'll be learning how to create sprite sheets from our clouds using the SideFX labs and export them to Unreal Engine. And so let's get started and let's get into it. All right, so we're back in our file, and the actual procedure is virtually the same. We start with our volume VOP, we cache it, like in the previous lesson. And of course, if you're not exactly sure what's going on, I would actually ask you to go and watch the previous video, because it explains in detail how we actually cache things, how we create all those things, and how we arrive to the result that we arrived to. So we actually don't need to use the retime. I was doing it for personal purposes, right? So again, we create the loop from our cache. Again, absolutely the same like in the previous video, nothing special here. We just make the start frame number 1, the end frame 64. We create the loop. However, before that, we can insert the pyrobake volume. However, in fact, we need to actually insert it after the cache. So anyway, we cache the looped result. We cache it. In this case, again, I cache it as a VDB. It doesn't really matter. BGOSC will work as well, because in this case, we don't need the actual VDB file, but we need some sort of a cache so they can work with it. So anyway, we say that the start will be 1, the end will be 64. Finally, after that, we need to get this pyrobake volume. Here it is. So literally the only thing I did here is I increased the density scale from 1 to, let's say, 7 or something like that, if I'm not mistaken. Yeah, it's 7.5. So what I did this is to have a little bit of more kind of like volumetric oomph to our animated cloud, so that I can actually tweak it in the shader in the material Unreal Engine after that. So what I'm saying is it's for a little bit of a better control in the material instance within Unreal Engine later on. So anyway, we have this, we have the cache, we have the pyrobake volume. Now what we need to do is we need to go to our out, and as you can see, it's already pre-configured because I basically did that before. But anyway, let's go through this again. So we have the flipbook textures. All right. So the flipbook textures, what it does is it will create the flipbook from our volume, from our animated cloud. If you remember, we have 64 frames, right? So we can go 1, 2, 3, 4, 5, 6, 63, 64. Then using the make loop, it interpolates and goes from the very beginning once again. So what it does is actually creates a 8x8 picture that is called flipbook, and it will go from frame number 1 to 64 and repeat once again. In our case, what we need to do is actually create a new camera. If you remember, you can position your viewport like here, hold down left control, press down left mouse button. Here's our camera. However, in this case, I want to have the resolution to be 1024 by 1024. So you can kind of like position it like this, or you can really zoom out a little bit, increase the focal length. Here we are. As you can see, it's the camera. Let me disable it so it doesn't annoy us a little bit. So here we are. It's a perfect position for our cloud. And let's say we're happy with this. Don't forget to unlock the camera so we do not mess with it when we rotate things around. The camera stays in position. We go back to our out, and in this flipbook textures, first we say that camera, in our case, for example, camera number 2, press accept. And the parabolic volume path will be this thing. So in our case, it's parabolic volume 1 or 2, doesn't really matter. The point is, it usually have to be, better be, the final node in your clouds. Go back to out and parabolic volume path. Let's say go to our geometry. And here it is. So what it does, it actually gets all the information from this parabolic volume and then works with it. So the intermediate images then getting composited and then getting exported, and everything being done in the background if you just press the render button. Let's go through those settings real quick so you kind of understand what's going on. So resolution per frame means that each of the little frame in the flipbook. Now let me just show you to showcase what we're talking about. Here is our flipbook, right? Kind of like this. This is frame number 1, 2, 3, 4, 5, 6, 7, 8. 8 by 8, and it goes like this. First row, second row, third row, and it goes to frame number 64, and then gets back to frame number 1. This is how it works. So effectively, each and any of those little things, of those little thumbnails, will be 1024 by 1024. I think it's enough. If you want like really super high quality, maybe 2K will be your choice. So the 3D resolution limit, remember, if you go and press here and go to texture, you can see that 3D textures are limited by 226 in each axis. However, this one will override this. And if you're going, for example, 2K by 2K, right? It's a good idea to increase the resolution limit. Otherwise, it will be kind of pointless because if your cloud will remain low quality, what's the point of rendering 2K texture per frame? However, this will increase the time for export dramatically. I would say anything from 768. If you don't have 12 gigs of RAM, you will be waiting a lot of time. So rendering usually takes from 15 to 30 minutes, depends on your PC specs. Next up is color space. The color space preferable in our case is ACES sRGB. And if you don't have the ACES, don't forget that you can actually get this from SideFX Labs. And as you can see, it actually comes with OCIO ACES 1.2. If you have set the SideFX Labs, like I showed you in some introductory videos, everything here will be just fine. You don't have to set up OCIO ACES, nothing like that. So it takes care of itself. So that's cool. Things here, we don't need this for this tutorial. So next up is the compositing tab. And here you will see that we have colors, MDC, normals, motion vectors. So in our case, the interesting part is that the motion vectors, first of all, they're a little bit buggy in the latest versions of Unreal Engine because the blueprints doesn't work properly and it hasn't been updated yet. And I asked the people at SideFX and they said they are working on it. You can see that the motion vector can be in R8G8, in SideFX R8G8, and R16G16. However, do not tweak it from R8G8 because we cannot convert it to SideFX R8G8 encoding, like I said, because the blueprint doesn't work. So this, again, will be just, default. So that's fine. Finally, the export, again, everything here can be by default. And the real-time shaders, you just press here and you can just go and copy the presets for the shaders for your project. All right, so with that out of the way, press render and it will create those flipbooks. So you have to wait some minutes and it will be done and we will go from there. All right, so first we can get our shaders. If we go into the real-time shaders, press this button and you will see that we indeed have this real-time shader like 5.0 SideFX Labs here. The alternative would be, well, if you install the labs, you don't need the alternative, but just to be sure, you can go to GitHub, SideFX Labs, download it from the releases here, like this, press the .zip, download it. Then what you would do is go to your downloads. Obviously, you will extract the thing, go inside this, go to the plugins, Unreal, and then you just copy, right? Copy, where is it? you just copy, okay, here it is. Then you go, in our case, to Unreal Engine, to our Electric Dreams, go to plugins, and then we just paste it here. And as you can see, I already have done that. You can see that SideFX Labs is here. In our case, this will be, if you press the settings and you enable the show engine content and show plugin content, you will see that if you scroll down enough, you will see that we have the plugins, and that's where you find the SideFX Lab content. And of course, we can go to templates, and here is our Material Pyro template advanced. So what we can do next is right click, create material instance, name it, for example, instance recording 2, and then I'll just drag it into the effects, move here, and you'll see that I already have a couple of material instances here, but just so that we understand what's going on, I will double click it and you will see that we have this material instance going on. All right, pretty good. So what we can do now is we can go back to work in progress. Here we go. Here is our render. And since we have already rendered this stuff here, you will see that indeed the export, it says directory. Well, here it is. And the next thing you want to do, right? The next thing you want to do is just select all these textures and drag and drop them into your Unreal Engine FX folder. You can actually create new custom clouds and drag and drop them here. You will see that we have some sort of importing going on. However, the important stuff here is that they are virtual textures, and our material instance will not get, as you can see, if I double click here, if I go scroll down to, for example, emissive color, right? And I go to our custom clouds and I want to import the ECD, you will see that it does not want to use that. So we double click here, start typing virtual texture, disable, press save, and now it will actually work just fine. So you do that for all of the textures. I have done that already. And you end up, if you just drag and drop everything into your material instance like that, enable this, and let's see what we actually have. MDC1, MDC2, and motion vectors. As you can see, something definitely starts going on. So like I mentioned before, it's a little bit buggy and it's slightly tricky to make it work, fine. So I will enable it on a box so we can see what's going on. You can make it as a plane, doesn't really matter. Let's have it as a box, and here we are. Okay, so first things first, the final color curve and the final color intensity does what it says. You can enable, increase or decrease the intensity and the curve. Curve is being like the gamma tweaking for our thing, but as you can see, this is really jerky. So what we have to do is advect motion vectors, enable this, and let's say 0.1. You can see that looks a little bit better. We can enable disable motion vectors. Now the problem with motion vectors here is that we actually do not have the motion vectors per se, because this, this cloud is not an actual simulation. It's basically moving our noise around. So it doesn't have the motion vector, so to speak. However, if we disable it, we will lose the information of our normals. And normals are important when you're trying to make the clouds or any other volumetric data respect the lighting that you have. In our case, it's the sun. So we will enable that and we'll try to fix it in another place. All right, so let's make it 001. So it's kind of really slow. And this, the encoding, as you can see, we can R16, G16H. If we go back to our flipbook, you can see that the composite for motion vector, we can have the R8G8, SideFX R8G8, or indeed this thing going on. However, like I said, the blueprint doesn't properly work in 5.2, so we have it on R8G8 without enabling these things. The motion vector scale, let's make it a little faster. The motion vector scale actually depends on your FPS inside of your Houdini. So in our case, this result, as you can see, we can we can get here and we'll see that we have 24 FPS. Effectively, what this number is 1 divided by 24, and this is what we have. So actually you can tweak it to see kind of different results. You will see that it offsets a little bit, like forward, backward. So you can tweak this if your export is a little bit too jerky for your taste. And finally, we can get to alpha curve. As you can see, we can increase or decrease the alpha. This is how you fix the kind of black parts that you can see sometimes inside of our cloud, thanks to the broken motion vector thing. And the final thing is the depth blend. If you enable it, there will be a lot of different tweaks, and we will take a look at them in our actual cloud plane. So how do we apply our material instances? Is we go and create basic shape, which will be a plane, as you can see. Okay, here we are. We have our plane, and we just drag and drop our material instance on our plane. If I enable real time, you will see, all right, here we are. It's in the shadow, so we don't properly see it. So as you can see, the plane here already has everything that we need, and the only thing we need to do is maybe increase the actual scale of the plane and move it to the position that we want. And as you can see, I think it moves in a direction I don't want. Okay, here we are, and we have another plane that acts kind of like as a cloud for our big rock here. Now the only thing I want to do probably is to maybe rotate it kind of like this, and I think this will work just fine. Let me see. Okay. So here we are, that's another plane, and as you can see, if I move it inside or outside, hopefully you will see it on the YouTube, is that it actually respects the depth of our geometry underneath it. And we can tweak it, as you might already imagine, actually in the depth range. So first things first, we have to enable the depth curve. Again, this is kind of like the gamma for how it operates. Next up is the depth offset, how much it is being taken backwards from our point of view just before we do anything to it. It doesn't really matter. We can increase it, we can decrease it. As you can see, things start popping in and popping out here. You actually can have it on the 0, doesn't really matter. The thing that matters is the depth range. If I make it 5, for example, yes, you will see that there is some things that have popped up here, but they are, in fact, should be in the back. So if I increase the depth range for something like 250, you will see, or actually 500, you will see that some things start to disappear, right? Despite the fact that it's actually just, like I said, it's just a plane, right? It's literally just a plane. The shader, in our case, works in such a way that it makes an impression that this data really is volumetric. So if I get my plane, dismiss. If I get my plane here, you will see that indeed it acts as a volumetric data. Now, 150 is a little bit too drastic here. 500 works just fine. Directional scatter is something you can tweak on your own. It's more of like thing that you, in my case, right there in this project, I kind of like dialed it in by hand, by, you know, just looking at it. If it looks right, it is right, kind of like the way I go about it. So anyway, that's the thing. If I get this to our folder and make the folder cloud planes, where is it? Okay. If I disable it, you will see that it looks, you know, not bad. It's all right. However, if I enable it back, it gives this little bit of depth, the thing that we really want. Again, just to reiterate, it's a little bit buggy. And again, the people who work and develop this stuff at SideFX, the SideFX lab, they told me that they are working on the new version and it will be better, hopefully, and that it should come out soon. So either way, this is looking pretty cool. And again, since it's just literally just a plane that you can enable, disable, you might imagine that it costs virtually nothing to compute and to render. This is not a simulation, this is nothing, this literally is a flipbook. But it looks pretty good, and it respects the lighting as well. As you can see, that looks really good. Again, without our clouds, with our clouds, right? So as you can see, the light is being respected, and this is why we have these normals. Okay, so this effect might not be like super drastic or whatever, but you can see this adds just a little bit of this 3D depth. This little cloud adds a little bit of atmosphere to the whole thing, and I think it looks pretty good, despite the fact it's a little bit buggy, but it works. That's that. Hopefully you enjoyed it. If you learned something, press the like button. If you have ideas, suggestions, write them down in the comments, and if you don't want to miss anything, just subscribe to the channel. By the way, all the assets are available on my Patreon, so if you want to support the channel and get the assets, you can have that option by subscribing to my Patreon channel, link in the description. And with that said, I wish you a good day and hope to see you in the next videos. Have fun and bye-bye.